So thanks very much for giving me this opportunity really to present my work today. So my talk gonna discuss the in vitro nanotoxicology and facing the challenges. First of all, as Steve already mentioned, how the nanomaterials now are providing a huge solution for massive disasters happened around us. So nanoparticle, known as uh, below 100 nanometer in size, are commonly used in pharmaceutical application to overcome a lot of these clinical and pharmaceutical challenges. From this diagram, just little tiny description how huge is the nanomaterials are out there. So there is variable amounts of chemistry, variable modification for the shape, for the surface modification, and so on and so on. So it is a huge piece of literature we are facing out there. The in vitro methods. The in vitro methods, either cell-based assays or in vitro non-cell-based assays, are the first cornerstone methods that we are using to evaluate the nanoparticle, evaluate their safety, evaluate their biocompatibility before we go into the in vivo study. But the in vitro methods are the ones that is commonly reported in literature, are the initial steps that we usually use to evaluate our nanomaterial before their in vivo experiment. We do see thousands and thousands of papers are out there in the literature, but sometimes we do lack the standardization of these methods. We do lack the importance of the optimization information that we should really share with our scientific community. For example, I'll present a few information from my doctoral thesis. For example, when we started my project in the nanotoxicology, I prepared around 8 nanoparticles, 200 nanometer of two different polymer, PLGA polymer, plus our in-house polymer BGA to BBL. Then I prepared the 500 size, then I prepared the 800 nanometer size with two different coatings, a negative coating with PVA and a positive coating with DTAP. When we done the characterization in vitro using distal water, which is usually common used to characterize your nanoparticle, and use the zeta size and method later on for the size and charge, then microscopy to lose the shape. Then you will see we got nice size around the 200, then the 500 for the 500 groups, then the 800. But there is a huge missed piece of data when it comes to characterizing this nanoparticle in your cell culture media. I did screen a lot and lots of these papers around to see how the nanoparticle behave in your cell culture media before you adding them to your cells. Because it will give you a nice piece of data. You will get a lot of information that will help you later on to explain a lot of your results after this. For example, I had to go to do a huge stability study and study this nanoparticle, their size and the charge in two different media. First one, I tried to use serum-free, just as a medium without any protein added, without any FPS, and added the same particle to complete medium that you usually commonly use is 10% FPS. But again, even the complete medium can be different from another type of cells to another type of cells. Might be the requirements that you have to add to your cell culture media going to be different. So we have to test the stability and the characterization of these nanoparticles before adding them into our cells. So I've done this for my experiment. Then I done the characterization at T0, which is immediately after dispersion and after 24 hours. What I have noticed is we are going to get immediately size increase once you start to add them to any type of cultural media. Because definitely the nanoparticle is going to interact with your component inside the culture media, and they are going to definitely absorb a lot of these components into their surface. Then it will increase their size later on. And even the size got higher and increased more over a 24-hour. For example, I choose the 24-hour because my exposure mostly is 24-hour. And most of the experiments for nanoparticles are for 24 hours exposure. So imagine the size is going up over time because it is interacting more and more with the medium surrounding this nanoparticle. As well, when we characterized the charge, we started to see lowering of the charge of the nanoparticle, while the positive nanoparticle started to acquire negative charge after the dispersion. And this was a bit like, that's okay to see, but okay. We studied this effect later on when we studied the different experiment and how the positive nanoparticle behaved a bit differently. And this type of protein coronas that have masked literally the charge of the positive and their impact later on in the cell culture. These changes of increasing the size and the changes regarding the charge differences were more manifested in complete medium rather than the serum-free medium. And this could be really understood because in complete medium, you're adding a lot of these proteins to the medium, and this will make a corona, a layer of corona around these nanoparticles that will make the particle changes in their size and charge. But this will help later on you as a researcher in understanding your experimentation and why you are getting the results, plus helping the readers later on to interpret some of the information. For example, to have some references, to have a bit of discussion for my results. Literally, like a handful of papers are mentioning the stability of nanoparticle in different medium that I was able to relate and use them as references to compare in my discussion. But hopefully it will be a common practice to study the stability in different media before we add them to cell methods. When we do the in vitro cell exposure, for example, this is our testing environment. We have the well, we are going to have the nanoparticle, and most of the assays or some of the assays, you are going to have to add the reagent, and you add the reagent to the medium, and your environment will contain the nanoparticle, will contain the cells, and will contain the reagents. In such cases, if you are unable to remove the nanoparticle from the test medium, because your material of interest inside the medium, like you are testing a release of enzyme or you are testing the inflammatory mediators that will be released, you can't really get off or remove the nanoparticles from the medium. So I show you, for example, a test I've done in my thesis. I've done the LDH total assay, which I'm using a lysis buffer. So I'm literally breaking the cells open, all of them, to see the amount of the LDH, which is an intracellular enzyme. Then I measured the LDH only release, which means I just measured the amount of the LDH in place of the supernatant mainly without opening all the cells open. And after I done this assay for the 24 hours, what I did see. So here, one type of my nanoparticle, and there is an increasing concentration until 2 mg/ml. Here is my negative control, which is untreated cells. Here is my positive control, which is 10% triton. So what I did see, increasing the concentration of the nanoparticles were associated with a decrease of the LDH total. So the highest two concentration here are associated with higher cytotoxicity. So you are expected to see a higher amount of LDH have been lost in the medium. When we done the release, the same increase in concentration at the last two or the highest two concentrations that we are seeing here. What we did see here is the highest two concentration showing a release of LDH, but no way is near to the spontaneous release of our negative control untreated cells. So here I suspected immediately these particles are interacting with the amount of the LDH released in the medium. Try to look around to see sources that are describing LDH interaction with polymeric medium or polymeric nanoparticle. I did found few papers that have been or tested LDH release, but unfortunately they didn't mention the result literally similar to my LDH release results, which I am expecting really there is an interaction is happening here. And they didn't test this possibility in the first place. They just got into the conclusion, we don't see an LDH release and that's it, which this could be really a huge mistake or giving a false information for the scientific community. Another test experiment. Here, another testing environment here. For example, here, my test reagent or my reagent gonna be metabolized in my cells. So literally, I have the ability to remove the nanoparticle from my testing environment. So here you start to think of your assay. If your assay, you are gonna add the reagent prior to adding the nanoparticle, that's gonna be brilliant. You add your reagent, then remove the reagent, you wash step, then add the nanoparticle for your exposures and measure after this. This is, for example, a result of ROS assay. I have to incubate the cell for 30 minutes with BSFDA reagent, then wash, then I added the nanoparticles, then I could see really the nice logic increase of ROS with the increasing concentration of my nanoparticles. That was nice. But when I have another assay, for example, I had to do 2 different ROS assays just to validate my result because I felt like ROS is showing toxicity and this could be a bit harmful. But okay. When we start to look into another different assay, which is the deep bread assay, unfortunately, the deep bread assay, I have to add it by the manufacturer protocol after the cellular exposure. So now I started to think, okay, should I remove the nanoparticle from the medium or not? There is no really standardized method for this. For example, I've done the assay with removing the nanoparticles, then I apply the 3 steps of wash of PBS. So what I did see nice increase of the ROS production was increasing the concentration. But when I just removed the nanoparticle without really any wash step, so a lot of these nanoparticles are present on the surface of the monolayer. See, the response have been different. So all these marks mean all these 3 responses here are significantly different from after the wash step. So if some assays have been reported like this and showing this, for example, these nanoparticles are showing no ROS production, or we are seeing a decrease of ROS production with increasing the concentration, we should have to think of interactions happening either between the nanoparticle and the reagent or between the nanoparticle and the cell causing this interference in such cases. I'll come to really my conclusion. So we have a huge piece of literature regarding the nanomaterial. I could understand the issues that we could think of as a scientific community when we come to test nanomaterials. Well, while the in vitro method provides a lot of these solutions to do more ethical investigation without animal study, you can do lots of these investigation to help you evaluate your interested nanomaterial. But we still faced with a lot of these challenges to characterize these nanoparticles and their safety. We need to have a method of standardization to ensure that everyone who will do this standardized method, we get the common ground that we understand about safety or the size or whatever information we should discuss. Very important information when we share the end results as publication. We usually don't really declare or share the information of the optimization. The optimization method is really of an extreme importance because it tells the readers or shares the information with the wider scientific community why these challenges have happened, how you managed to overcome this, what is the significance of this information to be known or published. We have to start sharing the information regarding optimization of nanoparticle testing. At the end, I'm asking you to be vigilant, everyone, while testing nanoparticles, be vigilant of incidents that might denote interference. Please investigate them more further, not just take it easy and you see a trend that seems logical in such way and you publish some information that might not be really the accurate to be published. I'd like to thank you very much. I'm ready for some questions and answers if someone have any. Thank you.
Thank you very much, Nashwa. That was a really important talk, I think, for the whole community. I'll kick off with a question, and that is, how do you think, and it's quite a big question, I guess, what's the best way to bring these common agreed measurements together? Where do you think we should do that as a community?
I think we should really work as a community plus the organization, either formal or non-formal organizations that are working to deal with this nanomaterial. We have to have a talk among ourselves to share our information and our views and carry on these views to the organization level to plan for standardization for testing or evaluation of nanoparticles.
And do you think we should go as far as, if you look at the exosome community, they published a set of guidelines, much like has been done for PCR for sequencing, around, you know, essential analysis? Do you think there needs to be a position paper on that for the international community?
I think so. I agree with you. I think we should be, as a wider community, participating on all these nanomedical applications. We start to have a talk among ourselves and share these literally critical points among ourselves. We have to be honest about it and talk about it. And we start to have a set of these standardized methods to be used for the wider community.